So, have you ever just looked at a solid wall or, even the palm of your own hand and really wondered what it's made of down at the absolute most fundamental microscopic level? Welcome to This Explainer. Today, we're taking on the ultimate scientific mystery, the true nature of our physical reality. For a long time, humanity thought we completely understood the building blocks of the universe, but it took a totally radical mind and an ingenious setup to prove that our reality was actually completely different from what we imagined.
So let's dive right into a seemingly simple question. What actually happens when you shoot a beam of radioactive particles straight into a solid sheet of gold? Now, that isn't just some wild hypothetical. It was the exact premise of one of the most legendary experiments in scientific history back in 1911. The core purpose of this study, the real driving goal, was to actively probe the unseen interior of the atom. Instead of just sitting around theorizing, the researchers wanted to physically interrogate matter to see exactly how it would react. And, well, the answer to this question completely shattered our understanding of the physical world. To see how this massive paradigm shift actually happened, let's look at part one, the man and his mission. Our scientific detective here is Ernest Rutherford. And he really wasn't the kind of scientist who was content with just accepting the established textbook theories of his day. The accepted reality at the time was something called the plum pudding model. Basically, it was this idea that an atom was just a solid, uniform soup of positive charge with a few negative electrons scattered inside it, kind of like plums in a pudding. But Rutherford had a massive driving mission. He wanted to aggressively test that accepted reality to see if that uniform soup actually existed. To pull that off, he somehow needed a way to literally see the invisible, which brings us to part two, the gold foil experiment. Rutherford and his team essentially had to build a microscopic interrogation room for atoms. First, they took a highly radioactive source, radium, and locked it tight inside a heavy lead box with just a tiny hole. Step two, they aimed the beam of alpha particles shooting out of that hole directly at an impossibly thin sheet of gold foil. And finally, step three, they surrounded that gold foil with a circular fluorescent screen that would flash every single time an invisible particle hit. So looking at the macro level here, you've got that lead-lined box on the left acting as our radiation cannon. That beam of alpha particles is basically a stream of microscopic probes fired like tiny, incredibly fast bullets at the target, the gold foil right there in the center. And that circular green screen wrapped around it is our detector. Now, because the accepted science said the atom was just a soft, uniform soup, Rutherford's team fully expected every single one of those alpha bullets to just punch straight through the foil with practically no disruption. Easy, right? But man, here is the plot twist. This is where the experiment yielded data that shocked the world. Yes, most of the particles passed straight through entirely undeflected, exactly as expected. But some of them deflected at these massive angles. And an even smaller fraction did the absolute unthinkable. They bounced right back toward the source. No way. Rutherford later described this as being as incredible as if you had fired a massive naval shell at a piece of tissue paper, and it just came right back and hit you. It made absolutely zero sense under the old science. To solve this crazy mystery, we've got to shift our focus from that macro lab setup down to the invisible world. Let's dig into part three, the physics of repulsion. All right, to figure out what went down, we have to visualize what was actually happening inside that incredibly thin sheet of gold. Over on the left, you've got your incoming beam of positively charged alpha particles. Those straight orange lines represent the vast majority of particles that are passing straight through the gold atoms as if absolutely nothing is there. But notice the ones that are turning back or bouncing away at sharp angles. They are hitting something entirely unexpected right in the dead center of those gold atoms. The crucial piece of the puzzle here is the underlying physics. The experiment totally proved that alpha particles are positively charged, and, as we know, positive charges repel each other due to electrostatic force. So that large angle scattering, that massive ricochet effect, only happens when those incoming alpha particles come extremely close to a highly concentrated, positively charged center within the gold atom. The stronger the repulsion, the greater the deflection. In that moment, Rutherford realized he had literally just discovered the atomic nucleus. This shocking data completely broke the accepted science of the era. The plum pudding model was dead. We needed a new paradigm, which leads us right into part four, a new atomic model. By actively testing reality, Rutherford completely overrode it. J.J. Thomson's accepted older model assumed mass and charge were just evenly spread out. But Rutherford's radical conclusions, which came directly from the undeniable fact that tiny particles were bouncing backwards off an invisible wall, proved that the atom's structure was something completely different. This resulting image is exactly what comes to mind today when most of us think of an atom, and it was born right here from Rutherford's conclusions. He proposed that the atom has this tiny, incredibly dense, positively charged nucleus sitting right in the center. Almost all of the atom's mass is packed into that tiny point. The electrons just revolve around the outside. But you know what the most mind-blowing conclusion of all was? Because most of those alpha particles passed straight through the foil, it meant that most of the atom, and therefore most of the physical matter in the entire universe, is actually just empty space. Now, you might be thinking, okay, sure, that's fascinating history, but why does a century-old experiment actually matter to me today? Well, let's look at part 5, real-world modern applications. Rutherford's initial quest to map the inner structure of the atom literally paved the way for our entire modern world. Because he proved the existence of the nucleus, he birthed the entire field of nuclear physics. That translates directly into the nuclear reactors that power our cities today. But it also gets super personal. Medical imaging, radiation therapy to fight cancer, and advanced nuclear medicine, they all trace their foundational physics straight back to this very experiment. The massive particle accelerators scientists use today to unlock the secrets of the universe, they are basically just highly advanced versions of Rutherford's radium box and gold foil. Which brings us to one final, honestly mind-bending thought. If Rutherford's gold foil experiment conclusively proved that the atom is overwhelmingly made up of empty space, what does that mean for your solid reality? The screen you are watching this on, the chair you are sitting in, and even the cells of your own body are practically entirely empty space, just held together by microscopic, dense centers of incredible force. It's an amazing reality to ponder, and it was all unlocked just because one scientist decided to deeply, actively probe the invisible world. Thank you so much for joining me for this explainer, and definitely keep questioning the reality around you.